All right. A very, very simple concept to give to you at the very beginning. I'll start to do this with the help of this. You know, when it comes to, let's say this is one of you. If I try to ask some questions from you, for example, how heavy are you? How heavy are you? For example, Mansha. I can see Mansha's name here. Mansha, how heavy are you? How many kilograms are you? You can just write. It's okay. Mansha, you are 52 kilograms. Nicolo, how heavy are you? Nicolo, I can give you 65 kilograms. No response. Can somebody tell your weight? Name is not needed. I will not mention the name. You can just write how many kilograms you are. Not how many kilograms, how heavy you are. No one is responding. Okay, you are reluctant to participate in the lesson. Okay, here we have a book. If I ask you how heavy this is, you can call it 2 kilograms. Or at the same time, if I take a CR book, you don't have 1 kilogram, maybe some 300 grams. I don't know exactly, maybe 300 grams. At the same time, if you take this one, it's a pencil. Okay. If I ask the weight of this, probably we can tell maybe 30 grams. And probably this one. What is this? This is small ant. How heavy is it? You will not be able to give the weight of the ant in kilograms. In grams? No. Maybe milligrams. You can go to milligrams to express the mass of an ant. Of course, we can give in kilograms also, maybe 0.00001 grams. Likewise, we can give some kilograms, 0.0001 kilogram. Likewise, we can express the mass of any substance using a unit, kilogram. And of course, if you think about this vehicle, the last drawing I'm going to draw here. Okay. If somebody asks the mass of this, nobody would want to give the mass of this in grams. Grams will not be suitable to express the mass of this car. Oh, kilograms? No, even kilograms will not be a favorable unit to give the mass of this car. Probably we can have 2 tons. A very heavy car, 2 tons. It has a weight of 2 tons. Likewise, when it comes to different types of substances, we have different types of units. For example, again, if I take this person, he has a mass of 52 kilograms. What exactly does it mean if I ask from you, when you say 52 kilograms, what's the meaning of it? You may think, oh, this is a weird question. 52 kilometers, even kilograms, even a grade 3 child understand what the meaning of 52 kilograms. But my question is, what exactly is 52 kilograms? It's like this. When you want to say that I'm 52 kilograms or 65 kilograms, the meaning is this. There is a unit. There is a unit. Actually, this is a piece of platinum. This piece of platinum is, they are in Switzerland. Switzerland, there's a museum. In that museum, this platinum piece has been kept. And this is not just kept in open air. This has been kept in an evacuated box. So if you go, you can see this platinum piece. And scientists tell that this has a mass. It has a mass. And what is the mass of this? This is a mass. Mass means is an object, okay? This mass has a weight of kilogram. Who says that? Scientists. They consider the mass of this substance is 1 kilogram. So when I tell you that you are having a mass of 52, you have a weight of 52, it means you're 52 times heavier than this platinum piece. If I say this book is 2 kilograms, it means its weight is 2 times this platinum piece. Likewise, whenever you say 52 kilograms or 55 kilograms or 60 kilograms or whatever, you think I'm 55 times heavier than that piece of platinum, which is considered to have a mass kilogram. So remember hereafter, when we express the mass of somebody, it means you are heavier than this platinum piece by that many times. 100 kilograms means you are heavier than that piece of platinum 100 times. Likewise, when it comes to different, I'm not going to talk about other units of mass. Likewise, now when it comes to an atom, okay, when it comes to an atom, let's say sodium particle, we can't express, of course we can, but we don't. We don't express the mass of sodium in terms of kilograms, not in terms of grams, not in terms of milligrams or tons, because this is very, very small. This is very, very small, and it's too light to compare in kilogram or gram or milligram units. So we have to have a separate unit. To express the mass of a sodium atom, therefore, let's say this is sodium atom. If you want to find out the mass of this sodium atom, we have a unit called AMU. AMU. The mass of sodium is 23. Relative atomic mass of sodium is 23. 23 unit is AMU. What is this AMU? I said the meaning of kilogram. Likewise, what is AMU? AMU means there's a small particle. This particle has a mass 1 AMU. So if I say sodium atom has a mass of 23, it means sodium atom is heavier than this 1 atomic mass unit. How many times? 23 times. Now, what is this 1 atomic mass unit? What is this particle? For this, scientists have found out one interesting thing. Okay, not that. We don't want this pentagon. I'll take this square here. This circular thing. This is a circle. This circle I have used to refer to carbon 12. Carbon 12. You know the meaning of carbon 12? Carbon has so many different types of isotopes. Carbon 13 is there, maybe carbon 14 is there, but I'm using carbon 12 isotope. Carbon 12 isotope. This carbon 12 isotope is divided into, see how many particles. You can divide this C12 atom into how many particles you can see here now. You have divided this into 12 particles, 12 parts. It is divided into 12 parts. And if I take one particle here, I will take this particle. Yes. What is the mass of this particle? This particle is 1/12 of the mass of the C12 atom. You understand that? Because if I consider carbon has some mass, I don't want to know how much it is. It has a mass. when this carbon atom is divided into 12 equal particles and take one of this, it has a mass 1/12, the mass of C12 isotope. This is considered as one atomic mass unit. One atomic mass unit is equal to 1/12 the mass of C12 isotope. Now, when I want to find out the mass of sodium, which is 23, it means a sodium atom has a weight which is 23 times this small highlighted part over here. So when I measure the mass of sodium, which is 23, compared to the mass of this 1/12 mass of C12 isotope, I give a definition to the mass of this atom, which I call relative atomic mass. Why do I call it relative atomic mass? Because I'm comparing the mass of sodium atom or any atom with 1/12 the mass of C12 isotope. So I can say relative atomic mass is an average mass. Relative atomic mass is the average mass of an atom, of an element, compared with 1/12 the mass of C12 isotope. This is the meaning of relative atomic mass. There's a questionable part also in this. When I say the relative atomic mass, it is the average mass of an atom of an element compared with 1/12 the mass of C12 isotope. You may ask, why average? It is because when I take sodium, sodium is available in different types of isotopes. So we have to take the average mass of all these isotopes of sodium for any element. There are isotopes. So we have to get the average mass of isotopes and compare that average mass with 1/12 the mass of C12 isotope. So again, if I say sodium relative atomic mass is 23, it means not one sodium atom actually. Average mass of an atom, there are so many different isotopes of sodium. You get the isotopes of sodium, get the average mass of it, and that average mass, how heavy is it compared to 1/12 the mass of C12 isotope? This is called relative atomic mass. Before we go any further, I want, if there's anyone, you can ask a question. I give 1 minute. You can write the question in the chat mode also. That's fine. If you want, you can on your mic and speak to me, please. Okay, ask question. There are some good questions. First question is, why do you want to measure the mass of anything compared with C12 isotope? There are reasons. Now, in the past, actually, scientists use hydrogen. Not C12, hydrogen one. So in that case, when you use hydrogen, for relative atomic mass unit, we use the mass of hydrogen straight away. And afterwards, scientists use oxygen-16 isotope. Oxygen-16 isotope. In that case, atomic mass unit is 1/16 the mass of oxygen. Now, from here, they have come to C12. Now, the standard method is comparing the mass with 1/12 the mass of C12. Even if you get the mass with, compare the mass with oxygen-16 also, you may get almost the same answer. But there are some reasons scientists say, oh, no. First, you use hydrogen. After, there are some limitations, so you go to oxygen. And later on, they have found out some limitation with oxygen also. So we come to carbon-12, and this is an accepted method now. Maybe in time to come, this carbon-12 will be replaced by something else also. Maybe when your kids come for A-level class, there will be not 1/12 the mass of C12, something else. And then also you are asking, is 1/12 the mass of C12 isotope is equal to 1 atomic mass unit? Yes. Yes. There are two questions. Okay. Can I go ahead with the lesson? If you tell me yes, I will go to the next part of the lesson. Okay. Let's go to the next part now. Mass spectrometer. First, we'll start the lesson with some definitions. I'm giving a note to you. You are expected to remember the following definitions. And for these definitions, marks are also given. In the exam, if you are asked to define what is relative atomic mass, all I have discussed about it. This is the average mass of an atom of an element, 1 mark, compared with 1/12 the mass of C12 isotope, 1 mark, where the mass of a C12 atom is exactly 12 atomic mass units, 3rd mark. Most of the time in exams, we get 2 marks. If there are 2 marks for relative atomic mass definition, you don't have to write the last part, where the mass of a C12 atom is exactly 12 atomic mass units. You can omit this part also. But then, all of a sudden, if you get 3 marks, you may lose this last point to lose a mark. Therefore, let us learn this whole thing as it is, whether you get 2 or 3, minimum 2 marks, maximum 3 marks. So, relative atomic mass is average mass of an atom of an element compared to 1/12 the mass of C12 isotope, where the mass of a C12 atom is exactly 12 atomic mass units. See, same thing is there for the next one also. Relative molecular mass. Let's see, water mass, carbon dioxide, nitrogen, molecules. Same thing. This is the average mass of a molecule. Earlier, an atom. Now, molecule of a substance, 1 mark, compared to 1/12 the mass of C12 isotope, 1 mark, where the mass of a C12 atom is exactly 12 atomic mass units. The only thing that changes is in relative atomic mass, we have average mass of an atom. In molecular mass, we have relative average mass of a molecule. Because a molecule also can be formed by different isotopes. So we use the word average. However, when it comes to relative isotopic mass, you know, isotopes are special things. I mean, unique things. In an element, of course, here, in an element, for example, sodium, there are different isotopes. For carbon, different isotopes are there. But when I say a particular isotope, it is one unique particle. So for that, we don't have to use average word. So relative isotopic mass is the mass of a particular isotope or the mass of a particular atom. We can write any of these words. Because RIM is their relative isotopic mass, in the definition, we'll write isotopic word. So relative isotopic mass is the mass of a particular isotope. You know, you must have by heart the rest of the thing, compared to 1/12 the mass of C12 isotope, where the mass of a C12 atom is exactly 12 atomic mass. It's very simple. I just cut and pasted. And then we go to relative formula mass. What is the first one? First one is atomic mass. Second one is molecular mass. Next one, isotopic mass. Now we go to relative formula mass. What's the meaning of relative? What's the meaning of relative formula mass? This formula mass is there for ionic compounds. Relative formula mass is a definition given for ionic compounds. This is the average mass of a single ionic unit of an ionic compound compared to 1/12 the mass of C12 isotope, where the mass of C12 atom is exactly 12 atomic mass units. What's the meaning of relative atomic mass unit? No, relative formula mass. Relative formula mass. Relative formula mass is this. I will take to explain this to you. Sodium. For sodium, we can use a relative atomic mass. For chlorine, we can use relative atomic mass. For Cl2, we can use relative molecular mass. Atomic mass, molecular mass, relative molecular mass. Relative molecular mass. However, if you take chlorine, chlorine is available in the form of Cl35 and Cl37. If you get the mass of this one, then this is relative isotopic mass. Suppose if sodium particle react with chlorine, sodium chloride, we have sodium plus and chlorine minus. Now, what is the mass of this? We can't call it atomic mass. No, for this one, relative atomic mass is not valid because it's not an atom. Relative molecular mass? No, we can't call it relative molecular mass also because this is not a molecule. Not atomic mass, not molecular mass. Can we say relative isotopic mass? No, relative isotopic mass is for isotopes. This is a combination of two atoms. This is sodium chloride. In sodium chloride, NaCl, if you take one sodium plus and one Cl minus, this is called an ionic unit. Ionic unit. So if you compare the mass of this sodium chloride ionic unit, one sodium and one chlorine together, if you get the mass of it compared with 1/12 the mass of C12 isotope, then we call it relative formula mass. This relative formula mass is for ionic compounds. So it is given in the note. Relative formula mass is a definition given for ionic compounds. It's the average mass of a single ionic unit of an ionic compound compared to 1/12 the mass of C12 isotope, where the mass of a C12 atom is exactly 12 atomic mass unit. I want you to go through this. I give 1 minute and try to digest this. Okay, start it. On the page number 2, we have a few more things to go through. We have learned these things, but still, shall we go through this? Atomic number. Atomic number. Shall write the answer for this. What is the meaning of atomic number? This is the number of protons present in the nucleus of an atom. This is also called what? Proton number. Atomic number of an element is a unique value. all the atoms of an element. All the atoms of an element means all the isotopes of the element. Have the same proton number. But different but atoms of different elements have different proton numbers. Atomic number is the number of protons present in the nucleus of an atom. This is also called the proton number. This is also called the proton number. Atomic number of an element is a unique value. All the atoms of an element, in other words, all the isotopes of the element have the same proton number, but atoms of different elements share or no have different proton numbers. And I want to give you one more small thing. I'll write over here. The proton number of a neutral atom. The proton number of a neutral atom is equal to its electron number also. Now, children, I have given so many things. I've given so many things under this heading atomic number. So in the exam, if you are to write atomic number, you must write this is the number of protons present in the nucleus of an atom. This is the answer. These things are additional information I have given to you. So remember, this is the answer for the atomic number. You can highlight this part. But remaining stuff also should be understood and must be remembered. Now we go to the next one. It is the mass number. What's the meaning of mass number? This is the total number. This is the total number of protons and neutrons present in the nucleus of an atom. This is also called the nucleon number. Nucleon number. Mass number of an element is not unique. Is not a unique number. Different isotopes of the same element have different mass numbers. Atomic mass or mass numbers. It has no relationship to electrons, so whatever. Total number of neutrons and protons is called the nucleon number also. Now you should know the meaning of nucleon. Nucleon means protons and neutrons together. I can say a proton is a nucleon. A neutron is a nucleon. So when somebody says, it's something like this. Now we have children, we have boys and girls. Now, a boy is a child, a girl is a child, but we can't say a child is a girl. I mean, when I say a child, we don't say whether it's a boy or a girl. But if I say a boy, definitely I know that's a child. But if someone says child, we don't know definitely what you are referring to. So this is something like that. Protons are nucleons. Neutrons are nucleons. So nucleon number means both protons and neutrons. Get that idea in that manner. We go to isotopes now. In the exam, we can write the definition for isotopes for 2 marks in this manner. These are atom of the same element having the same proton number. You get 1 mark for that, but different nucleon numbers. Nucleon numbers, or else we can say different neutron numbers. You get the 2nd mark for that. You don't have to write both. I mean, nucleon number or neutron number, you don't have to write both. You can simply write, these are the atoms of the same element having the same proton number, but different neutrons. Different neutrons. That will be okay. Okay, copy down this, please. We talked about relative atomic mass, relative molecular mass, relative isotopic mass. So from there, we'll see what is our next part. Straight away, we are going to mass spectrometry. Mass spectrometry is used to determine the relative atomic mass of elements compared with this with the C12 scale. It's a separate lesson now. We will go to the discussion of mass spectrometer operation now.